So on our last lesson about parabolas, we learned how to graph parabolas in 3 different forms: vertex form, standard form, and intercept form. Well, today we're going to talk about 2 other components of a parabola. One's called the focus, and one's called the directrix. And I don't expect you guys to be masters of these, but I'm going to let you use this formula chart on all of your assessments, and it's going to help you calculate the focus and directrix for any parabola. So, look over this chart, notice the axis of symmetry, and they call this a standard form. We actually called this the vertex form on our notes. Different books call it different things. Notice the axis of symmetry is x equals h, which is the x-coordinate of the vertex. The vertex is at hk, which is something we already knew. The focus is going to be a point at h, comma, and then k plus 1 over 4a. Now the a value is the same a value that we know about, where it's the number in front of the parentheses. And then the directrix is an equation of a line. In our case, it's always going to be a horizontal line, and it's at k minus 1 over 4a. And of course, if the a is positive, it opens up, and if the a is negative, it opens down. So let's see this in action. The original form that we're going to look at for this parabola is in vertex form, 2 times x minus 3 squared minus 4. Of course, the a value is the 2. That would be the number that's in front. The vertex is at 3, negative 4. And of course, the axis of symmetry is at x equals 3. So our next component that we need to identify is where the focus is at. And if I go back up to my chart, the focus has the same x-coordinate as the vertex. So this is a typo. Sorry, let's fix that. Should be a 3. And then the y-coordinate of the focus is going to be the original k value, but then plus 1 over 4 times the a value. So if we were to simplify that, and I would just type it on my calculator, or, if you just know negative 4 plus 1/8. Notice how we're leaving it as a mixed fraction, negative 3 and 7/8, because we're going to be plotting this. Improper fractions don't really help us any. Now for the equation of the directrix, it's going to be the k value, which we know is a negative 4, and then we're going to subtract the 1 over 4 times 2. So in our case, it's negative 4 minus 1/8, which of course is negative 4 and 1/8. Notice that the directrix is an equation of a line, and the focus is an ordered pair. So the next equation, and let me back up a second, make sure that didn't have a typo. Nope, we're good. Sorry, I'm proofing this for the first time, apparently. Let's see what this looks like. So we're going to actually graph this next parabola, and then we are going to identify the vertex, axis of symmetry, and the direction of it opening up or down. And we're going to identify the focus and the directrix. Now notice on your paper there is no graph. I just want to graph this so you guys can understand what we're looking at. So I'm going to start with the actual graph of the parabola itself. The vertex, of course, is at 0, 0, because there's 0x and 0h and 0k. And then when we think about a t-table, remember we control the numbers that we put into the t-table. I'm going to pick symmetrical points. So I'm going to choose a negative 1 and a positive 1. If I were to substitute in the negative 1, that'd be negative 1 squared and then times another negative 1. So it'll be a negative 1. Same thing when I substitute in the 1, I get another negative 1. So I'm going to plot my next 2 ordered pairs, and right away, pretend that hit. It's worse. I notice right away that I have a down opening parabola, so I'm going to make a little note that it opens down. The axis of symmetry is x equals the h value, so x equals 0 for the axis of symmetry. And notice it's an equation of a line, like always. And then they want us to identify the focus and the directrix. So we're going to start with the focus. Remember, the formula for focus is h and then comma k plus 1 over 4a. So the h is 0, and then k plus 1 over 4 times the a value. The a value in our case is a negative 1. So if I go ahead and I simplify what I can. The focus is at the point 0 and then a negative 1/4. Now, it's a little hard to graph this, especially if you don't have the wrong kind of scale, but 0, negative 1/4 is like right here. And I'm going to signify my focus with a little asterisk, a little star. For the directrix, he is an equation of a line, and it's k, which is 0, minus 1/4 times a. So that is going to become negative 1/4, which is a positive 1/4. So the equation of our directrix is the line y equals positive 1/4, which would be a horizontal line. Okay. Hopefully you can draw a straight line, because I can't. At up 1/4. So the idea about focus and directrix is that the distance from the vertex to the focus and the vertex to the directrix should be the same measurement. And we see, kind of, that the distance from the directrix to the vertex is a distance of 1/4, and the distance from the vertex to the focus is also a distance of 1/4. It's a little difficult to see, but that is what a parabola is. It is a graph that is equidistant from the focus to the directrix. We're going to do, hopefully, a cute little activity showing you how it is equidistant. So this next question, the vertex, of course, is at the point -4, -5. It is going to open up because the a value is a positive 1. What else do we have to do? Oh, axis of symmetry is x equals -4. And of course, we're going to graph this so we can see what's going on. So -4, -5. And then if I went ahead and made my little t-table, just like we did back in 5.1, I'm going to pick something to the left and something to the right. If I were to plug in a -5, I would get, let's see, 1 minus 5 is -4. Same thing down here. And then, of course, we're going to, oh, geez, graph. As always, I'm drawing on a tablet, so your graph should look much nicer than mine. So our next task is to find a ordered pair for our focus. Our focus is at the point h, and then k plus 1/4a. So our h is -4, and then our k is -5 plus 1/4, and then the a value is a 1 in this case. So simplifying what I can, the focus would be, let's see, -5 plus 1/4, which is -4 3/4. Again, improper fractions wouldn't make a whole lot of sense here. So if we think about where the point -4 3/4 is, it's roughly right there, which is my focus. Now, the focus point should always be inside of the parabola hug. It should never be outside of it. The last thing we're going to have to find in this equation is the equation for the directrix. So it is k, which of course is the -5, minus 1/4 times a. So -5 minus 1/4 is y equals -5 1/4. The directrix should be a horizontal line outside of the parabola, which, again, I wish I could draw a little better. Oh, geez. But, again, the distance between the focus and the vertex and directrix should be the same measurement. So again, the distance here is a 1/4 unit up and a 1/4 unit down. Okay, our next example has a vertex at the point 2, 1. It opens up because our a value is positive, and this is going to be quite a skinny little parabola. So 2, 1, so right there. And if I thought about making a t-table, pick something to the left and something to the right. Let's see, if I put a 1 in, it'd be -1 squared is 1, 4 times 1 is 4, 4 plus 1 is 5. So 1, 5, and 3, 5. Now, oh goodness, oh, missed totally. I can do better than that. Your focus calculation is using the same formula that we were just working with. So the focus point is at h, which is 2, and then the k plus 1 over 4a. Now this is less than exciting. 1 plus 1/16 is just 1 and 1/16. Really difficult to graph. So 2 and then up 1 and 1/16. I can't even graph it because I already covered it up, but you can kind of envision he's just inside the parabola. And then the equation for the directrix would be y equals my k value, which is a 1, and then minus the 1 and 1/16 that we're about to find. So 1/16. 1 minus 1/16 is 15/16. So again, these are very difficult to graph on such a inappropriate scale. That's a 15th, sorry. But my dots are bigger than my lines even. But you can envision a distance of 1/16 up and 1/16 down is why this works. Number 4, the vertex is at 6, 4. And let's see here. It opens up because the a value is positive. And I'm not even going to bother graphing this one for now. Maybe we'll do it later. But if I'm trying to calculate the focus point, the formula is, again, you can always use this on a test, h and then k plus 1 over 4 times the a value. Now be careful on your calculations for this problem, because 4 times 1/2 in the denominator is really a 2, so it's 4 plus 1/2. So 6 and then 4.5 for our focus point. And then for our directrix calculation, it's y equals the k, whoops, that was not the k. Sorry, k value is a 4. And then minus the 1 over 4 times the 1/2. So 4 minus 1/2 would be y equals, that's 4 minus half, what did I just say, 3.5. So if we graphed this, it would look lovely. So in the next section, they actually have you graph them. If I had my life to live over again, I would have given you a much better scale to work with. But this problem is already done. The a value is a 1/3, and you'll notice they did all the calculations for you. They found the vertex at 1, 2. The axis of symmetry is x equals 1. The focus, after they did some calculation right here, 4 times 1/3 is 4/3. That's a little hard to do. If you did 2 plus 1 divided by 4/3 on your calculator, you would have to put the 4/3 in parentheses. But remember, dividing by a fraction is the same as multiplying by the reciprocal, so it'd really be a 2 plus 3/4. And that's how they got their 2 3/4. I'll try to make the fractions a little easier on your assessments that you can do easily in your head, but of course use your calculator to verify it. So they've already graphed the parabola for us, but you can envision the focus point as being over 1 unit. This is the origin, by the way. So over 1 unit and then up 2 3/4 units. So just right above there, the directrix, which I don't think they even calculated here, but we could easily do, is the k component, which is a 2, and then the minus, remember we decided after we calculated this it'd be a 3/4. So 2 minus 3/4 is 1 1/4. So a little bit above the 1, oops, it's going to be your directrix calculation. So let's continue on. This time they give you the vertex and they give you the focus, and your job is to come up with the equation of the line. So I know that if I need to move this a little bit, let's see, oops. If I know my h and k, that's part of the issue. I also need to know the value of my a for my equation. And this focus point, this part right here is going to help me calculate the a, because look at how that number is calculated. 5 is k plus 1 over 4a. Remember, this is the h and this is the k. So using my formula from the focus component, the y component of the focus, it says 5 equals k, which is a 3, plus 1 over 4a. And now we're going to solve this equation. I'm going to subtract the 3 and get 2 equals 1 over 4a. And now I want you to treat it like a cross multiplication problem. And then solving for a, you find that he is a 1/8. So going into my vertex form, which again they call standard form, but we call it vertex form. If you just plug in the components, you get a 1a x minus 3 squared plus 3. And that is your answer to that first question. I don't know why, but I like this part better. Same idea here. They give you the vertex, so here's your h and here's your k, except this time, instead of giving you the focus point, they give you the Directrix equation. So remember, you can use this chart, whatever. The y value, or the equation for the Directrix is y equals k minus 1 over 4a. So negative 6 is the Directrix. It's supposed to equal k, which we see as a negative 5, minus 1 over 4a. So if I do a little calculation, I'll be able to solve for a. I get negative 1 equals negative 1 over 4a. And then remember, we're going to cross multiply and divide. So negative 4a equals negative 1. Solving for a, whoops, you get a equals 1/4. So taking the 3 parts that I need for my equation, here's my vertex, here's my a. Going back to my equation skeleton, it is the a value, x minus h, which is a 4 squared, and then plus k, which is a negative 5. Okay, same kind of question here on number 7. This is my h, this is my k. 1 is supposed to be found by using this formula right there. So 1 equals the k value we just decided was a negative 1 minus 1 over 4a. So if I were to add the 1 and then treat this like a cross multiplication problem, I would have 8a equals 1. Oops, I think I lost a negative. It equals negative 1. So a is negative 1/8. Oh, I just realized I hadn't been graphing any of those questions. I'm going to assume that you guys can graph beautifully. Sorry. So y equals negative 1/8, parenthesis, x minus the h, which is a 4, squared, and then plus k would be a minus 1 for this question. Whoopsies. Let's go ahead and graph this one. So our vertex, here's the origin, is at 4, 1, 2, 3, 4, negative 1. I'm going to kind of fudge this one in. He's quite wide. Again, if this was a homework or an assessment problem of some sort, I would get accurate points, but we're just going to pretend for now. The Directrix was y equals 1, which is up here. Oh, goodness. And then you'll notice, if it was a distance of 2 units up, if I go 2 units down, that'll be where my focus is located. Now, we could have calculated that algebraically, but sometimes visually it's more appealing. This last question, graph it, identify the focus, Directrix, and vertex. So kind of like how we began the problems, except we're going to graph everything. So the vertex is pretty easy to identify. That's 2, 0. And if you remember how this is identified, this is the h and this is the k. So I really wish I had my formulas in front of me, but I could always back up. Remember, the focus is at h and then k plus 1 over 4a. Hopefully you notice that the a value is just a measly little 1 today. So for the focus point, he's got the same h value, and then k plus 1 over 4 times the a value. So if I kind of simplify that, 0 plus 1/4, of course, is just 1/4. So that's your focus point. The Directrix is equal to k, which is 0, and then minus the 1 over 4a. And you might get really good at realizing that 1 over 4a is the same 1 over 4a for every part of that problem, so you don't have to keep calculating it once you do. But 0 minus 1/4, of course, is going to be y equals negative 1/4 for my Directrix equation. So I have found all 3 components that they were looking for. Of course I should graph it, but I'm kind of in a rush, so I'm not going to. And then this last question, the vertex is at negative 3, 4. The focus is the same h, which is negative 3. And then you take your k value and you add 1 over 4 times the a value. Now this time the a value is a negative 1. So my focus, when I simplify this, this is 4 plus a negative 1/4. So 4 minus 1/4 is 3 3/4. So there's my focus point. Here's my vertex. Last thing I need to find is the directrix. He is my y value, and then I'm going to subtract that 1 over 4 times a. Don't lose your negatives here. This becomes a 4 minus a negative 1/4 is 4 plus 1/4. So the equation for my directrix is 4, 4 and 1/4. So that is your very brief introduction to focus and directrix. I'm hoping we can do a fun little activity using ropes and partners, and we're going to line up in the atrium, and I'm going to show you about the equidistance from a directrix to the vertex to the focus, and hopefully it'll all make lots of sense. But remember, you always get this little cheat sheet of formulas in front of you when you take a test or a quiz or any sort of assessment for this unit.